Today, we're going to learn another method for taking derivatives, and this is going to work for functions that we don't know how to take derivatives of yet. So we saw in class last time that things like x to the fourth minus 4 to the eighth, that we could take the derivative of those by using a bunch of product rules or by FOILing this expression out and then using the power rule. Both of those methods are painful and involve a lot of multiplication. So today we're going to learn something called the chain rule that will make this much less painful. It will also work with functions, with some functions that we could not take the derivative of using the product rule yet. So that's what we're going to do. Before we do that, we need to think about composition of functions because chain rule is going to work for a composition of functions. Remember, product rule worked if we had a product of functions. Quotient rule works if we have a quotient of functions. And you would think we maybe should call this the composition rule, but instead it's called the chain rule. The chain rule works for compositions of functions. And I'm going to review function composition before I get into the chain rule. So this is pre-calculus review, hopefully. So if I start out with the functions x squared and sine of x, if I look at that composition f of g of x, what am I going to get? So this is f of sine of x. I can just replace g with sine of x. And now what this is asking is if I plug anything into the function f, that means I replace all the x's in f with the expression on the inside here, so sine. So I'm going to get sine of x quantity squared. Okay, we notice that this notation is f of g of x. That is not f of x times g of x. These are not the same thing. So notice that f of g, the notation that I used here, does not have an extra x in there. So this is a composition that we were just working with. Try this next one on your own before you watch me do it. But what I'm going to get here is this will be f of 5x, and then I replace the x in f with 5x, so I get e to the 5x. Okay. The chain rule is going to tell us how to take the derivative of expressions like this and this. When we use the chain rule, we're going to be given this expression over here, and we're going to have to go backwards to figure out what f and g were to give us that expression. So let's get practice with that. So these next two examples allow us to do that. So I've been given the final answer. Essentially, I've been given this piece, and I have to go back and figure out what these pieces will be. Okay. So if I look at this first example, or I guess the third example here, I need to identify what the function f and g will be. The way that I think about this is I like to think about this as an outside function and an inside function. And we can think about what that means in a second. Here, if I wanted to know what the inside function is, maybe you would think that's the 3x plus 4 that lives inside something else. If the 3x plus 4 is my inside function, then I replace that piece just with an x, and what's left behind is my outside function, so that would be x to the fourth. Okay, and so what I claim is that if we can figure out what the inside and outside functions are, then my outside function is my f of x, my inside function is my g of x. And then if I look at this, if I look at f of g of x, just to make sure that this should be equal to my original expression if I've done things correctly. If I do that, then this will be f of 3x plus 4. And then if I replace the x with 3x plus 4, I'm going to get 3x plus 4 to the fourth. So that's good. It looks like I did things correctly here. And then similarly here, if I look at my outside and my inside functions, I always think the inside is the easier function to determine. See if you can figure out what you think these will be. I think my inside function is probably going to be e to the x, which leaves cosine of x as my inside, or as my outside function. So cosine is the outside function is f of x, and my inside function is g of x. Okay, I'm going to record the chain rule in the next video, but what the chain rule is going to allow us to do is if I want to take the derivative of something like one of these two things, then I have to start out by identifying the inside and outside function. I'll take their derivatives, and then the chain rule will tell me how to put that all back together again. And I'll just do that in another video.